Okay, question 2. Define the following terms. Now, I'm not going to write them in, but I will explain what they are. So an atom is the basic unit, the basic thing that all substances are made out of. So they're a tiny particle that is made out of protons, neutrons, and electrons. So the two key ideas I'd hope to see in here is that you're basically saying they're a particle, tiny particle that make up all the substances around us, and that they're made out of protons, electrons, and neutrons. What is a molecule? A molecule is a small group of two or more atoms that are chemically bonded or joined together. So it's a little group. You've got two or more atoms joined together. What is an element? An element is any substance that contains only one type of atom. So that's your definition. A substance that contains only one type of atom. And it doesn't matter how they're arranged, whether they're in pairs or on their own or in bigger groups, whether they're molecules in groups or whether they're not, whether they're individual. An element is something that only has one type of atom in it. A compound is a substance that contains two or more different atoms, so two or more different types of atoms, chemically joined or bonded together. A mixture is a combination of different particles. It can contain elements and or compounds. So it could be a mixture, a combination of two elements, or it could be a combination of two different compounds, or a compound and an element. A mixture contains different particles, and a mixture can be separated. So that's your definition. A mixture is a substance that contains different particles or molecules, and it's a substance that can be separated. So we'll look at a mixture in just a second in the examples below. Alright, so let's have a look at, guys, my examples here. Alright, water is a compound. We know its formula is H2O, so it's two different elements, hydrogen and oxygen, combined together. This is salt, sodium chloride. You can see it's got sodium and chlorine. We've got two different elements joined together, so it's a compound as well. Now we've got O2, so the two oxygens joined together, but they're the same type of element, same type of atom, so it's an element. Gold, we can find gold on the periodic table. So gold, a lump of gold, is made out of purely nothing other than gold atoms, and that's why it's an element. This one here is a compound. We can see carbon, hydrogen, and oxygen, and another hydrogen on the end. We can see different types of atoms, but they're chemically joined together to make one group, so that's a compound. Juice is a mixture. It's got different compounds in it. It's got water, which is one compound, but it has things like vitamin C, and it's got citric acid, different compounds that make up juice. So it's a mixture of different compounds. Milk is also a mixture of different compounds. It's mainly water, so most of what's in the milk is water. If you boil off or evaporate off all the water, you're left with basically milk powder. So you can make up the milk again by mixing the powder with water. But milk also contains fat. We know milk contains calcium. So we've got a combination of compounds and elements in there. It's a mixture. We can separate it into those things. So this one up the top, if we look at these examples, this one here is a compound, and it's two or more different atoms. We've got a blue one and a pink one joined together. And if you have a look at them, all of the groups, the particles, are the same. So it's not a mixture because we wouldn't be able to separate them. If I put some of these in one pile and some of them in another pile, each of the piles would still look the same. They'd all have these double groups, the blue and the pink, these molecules with a blue and a pink atom joined together in each pile. So this is a compound. Two or more different atoms of different types joined together. This one here is an element. Straight away I can see we've only got the blue atoms. It doesn't matter how they're organized, whether they're in groups or on their own, it's an element. And this last one is the mixture. And we can see here it's a mixture of a compound. If we had these two on its own, like the first example on this side, like the one up the top here, these two here would be a compound, and the pink ones, the single circles, if they were on their own, that would be an element. So this is a mixture of a compound and an element. But basically we know it's a mixture because the particles, or the molecules, the the particles that make up this substance are different, and we could actually sort them into two piles. We could put these compound ones in one pile, and we could put this element, the pink ones, in a separate pile, and we'd have two different piles. If you look at the ones up the top, if I separated these into two piles, the piles would be the same. If I separated these ones into two piles, the piles would be the same. So the mixture here can be separated into its different components. In this case, we'd have a pile with a compound in it, and we'd have a pile with an element in it. Cool, I hope that was helpful, and we'll get on to the next question.